Large language models have taken the world by storm in recent years, powering everything from chatbots and virtual assistants to language translation apps and creative writing tools. But what makes these models so powerful? So, how do they manage to generate text that's often indistinguishable from human language? In this article, we'll delve into the inner workings of large language models and explore their technical underpinnings in detail. Whether you're just curious about how these models work or looking to develop your own, this guide will provide you with a comprehensive understanding of the magic behind them. How large language models work. At its core, a large language model is a type of artificial neural network designed specifically to process natural language data. These networks consist of multiple layers of interconnected nodes, also called neurons, that learn to represent language patterns through exposure to vast amounts of training data. The key to their success lies in the use of deep learning techniques, which allow the model to adapt and improve over time based on feedback from users like you. Layer 1. Tokenization. The first step in processing any piece of text is tokenizing it, breaking it down into individual words or tokens. This is done using a combination of rule-based and machine learning-based approaches, depending on the complexity of the input. For example, punctuation marks may be handled differently than other characters, while specialized algorithms can help identify parts of speech such as nouns, verbs, adjectives, etc. By dividing the text into smaller chunks, each layer can focus on specific aspects without getting bogged down by irrelevant details. Layer 2. Embeddings. Once the text has been broken down into tokens, the next step is to convert each one into a numerical representation known as an embedding. Essentially, this involves mapping each word onto a dense vector space where similar items cluster together close by. Think of it like organizing books on shelves according to subject matter. Now imagine those same books being represented visually instead of physically. With embeddings in place, subsequent layers can leverage contextual relationships more effectively when making predictions or generating output. Layers 3 to 6. Encoder-decoder architecture. The heart of most large language models lies within their encoder-decoder architecture. This consists of three main components. Self-attention mechanisms, allowing the model to focus on different parts of the input. Feed-forward networks, processing sequential inputs independently. And finally, another set of self-attention mechanisms followed by a final linear layer producing outputs. Together, these elements enable efficient communication across long sequences while capturing subtle nuances along the way. No small feat given how complex human language can sometimes seem. Output generation. Finally, once all the previous steps have been completed, it's time to generate actual output, depending on whether you want plain text or something more creative, like poetry or even entire stories.